Thanks, Mike. Thanks, everyone, for coming. So we'll be talking about making Spark application development fast and easy. So I'm Shivnath Babu. I'm a professor of computer science at Duke University. And that's where I met Lance. So I also run a startup, Unravel Data Systems, and you'll probably hear more about some of the things I do in the talk.
Yeah, my name is Lance. I'm a founding member of machine learning team at Box, so I work a lot with Spark. My background is mostly distributed systems and statistics, and I also went to Duke for my undergrad and graduate school. So yeah, just a little about how we use Spark at Box. So we unwrapped Spark maybe like a year and a half ago at Box, and like a couple of use cases coming up for us. We have topic modeling. As you can imagine, there's a lot of documents we play with at Box. We have label propagation and things like anomaly detection for like a lot of our time series graphs.
So why do people like Lance love Spark, right? So there are many, many reasons, and this is like what you see on the slide here is why we think a lot of developers love Spark. This is a line. It's not our line. It's a line from the Spark research paper that won the Best Paper Award. So let me read it out to you. Like, we believe that Spark is the first system that allows a general purpose programming language to be used at interactive speeds for data mining on large clusters, right? The key phrase here is a general purpose programming language like Scala, Java, Python. And anytime when you have such great power, look what happens, right? You get great complexity.
Right, so we want to run you through a pretty simple Spark execution pipeline just to unwrap the onion a bit. So on the very top layer, we're looking at the Spark program. To your left, a couple of like transformations applied on our data. But the point is, on the top layer, you have your like logical representation of what is happening. You have your data, you apply certain transformations, and like this is the application layer that you normally work with. Underneath the hood, like what Spark does, as I'm sure most of you know, is they take this logical representation that you've written in the form of a program and divide it into what they call stages. So stages are delineated by like the need to shuffle or like write data out somewhere. So stages, this is abstracted away from you. Within each one of these stages, each stage is broken down into many tasks, and a task is just a logical representation of work. And finally, like each one of these tasks have to be executed somewhere, and so they're executed within the JVM of a worker. So like all in all, the point I'm trying to make here is that there's many layers to the onion. So there's the application layer, then you have your stage and task information, and then finally it's executed in an executor in the JVM. So very quickly, it gets very complex.
Right. When you have, again, a lot of complexity that's happening, things can go wrong, and often they will, right? So let's see what are some of the things that can actually go wrong. So first of all, failures, right? So often we hear that when application devs like Lance are developing their programs or running their Spark SQL queries, query failed. It failed after 6 hours, right? So what is worse, that a query that you're waiting to actually finish failed after 6 hours, or you actually get a nasty stack trace like this at the end, right? I'm sure a lot of you who have used Spark have probably seen these sort of bad stack traces. So applications can actually fail, right? Once you have gotten your application running, like if you have such a complex Scala program that's running, how do you know that it's correct? How do you know that the results being produced are correct? Your company might be depending on the results for some decision making, right? Okay, it's running correctly, it's actually looks correct, right? So next thing comes like the performance part of the tuning and diagnosis and understanding bottlenecks. And sometimes you have pipelines that might be running hourly or daily, and those have to meet SLAs, right? Like a 4-hour SLA. So that can actually be hard. And of course, how often, like ops people here have probably heard, hey, it worked on the dev cluster, right? I don't know what is going on in the prod cluster, right? So once you get your program running, then you have to ensure that it scales, that it can handle the amount of data that's being thrown at it probably on a daily or hourly basis. And like probably the worst thing, hey, my program ran fine, but it brought down the entire cluster, right? So these bad apples. A lot of such issues can actually happen, and why do they happen? Many times the problem might be in the application itself. Maybe you didn't you didn't choose the right set of transformations. Maybe you gave the Spark driver a lot of work to do. Your data structures might be bloated, right? Maybe the problem is not in the application, it might be in data. And often data is skewed, right? And that can cause one worker, one executor to do all the work. And then a cluster that is like 100 nodes might be running at the power of a single node, right? And Spark itself has problems. Like we have done a lot of testing of Spark, running it on terabyte scale data sets on the Amazon cloud, and Shuffle actually gives a lot of trouble. And that's something the community has been definitely improving a lot on. And one thing to keep in mind is this lazy execution, right? Trying to pipeline, do a lot of things only on demand, and that can often lead to obscure problems. And finally, resources, resource contention, lots of like such problems happen. And what is very interesting is an application problem can cause all of these things you see on the left side of failure, like cluster crashing, bad performance, and not only application problems, all the others can cause all the problems on the left side. So you're dealing with this like huge mess of like problems and causes and whatnot, right? So Lance, how do you deal with these problems today?
Yeah, so we've all seen a lot of these problems. And the first thing you would probably go with is, Spark's default UI. It's very good. It first shows you, as you've all seen, application level breakdowns, useful metrics like latencies for applications. Then you go through like stages. You see some like useful statistics about like the distribution of tasks and how they executed. And so yeah, it's bundled in that sense. And here are some sample screenshots from that. But sometimes that's not enough. So you step back and you say, okay, that's what's happening with my Spark cluster. You want to zoom out a bit and get a slightly bigger view. Maybe you use a Ganglia, or maybe you use a Cloudera manager, and you say, hey, what's actually happening in the machines that Spark is running on? Maybe there's other applications contending with Spark. So very quickly, you now have 3 different things you're juggling. When you're trying to debug, you're trying to form the story of why it broke. You have your code, the actual logic that you've written. Then you have the Spark UI, a lot of Spark-specific things. Then you also have your machine metrics. So it's, again, very quickly, it gets too much to look at, and everything's all over. The next thing that you might want to do as well, kind of bare bones, you go into the machines, and in the end of the day, Spark is a distributed applications. So there are logs that are sitting in all these machines. But as I'm sure all of you in this room know, going into the machines, watching for logs on specific workers, it gets very cumbersome, and they're spread out, incomplete, and generally a lot to juggle and look at.
There has to be a better way, right? There has to be a better way for application developers to deal with these problems, detect them, fix them. So what we have been working on in this collaboration, as I said, I'm a professor. I've been doing these sort of tuning, building software that can help manage systems for a while now. And we did some work on Hadoop, and a project called Starfish back in the day. This was in 2009, 2010 timeframe, right? And when we actually started seeing that Spark usage is rising, and people like Lance, who was who was working with us at Duke, and once he moved and started building applications and started seeing these problems, we got together and we joined forces to come up with first, what is the methodology to follow for some software that can help application developers deal with problems like this. So we came up with 3 tenets or mantras, as we call it. First is it's called visualize, right? So a developer like Lance should not have to reach out into machines, logs, Spark UI, Yarn application logs. Why can't software bring all of these related data in one place and not just dump it at you, actually show it to you in a nice and consistent way so that the application developer who's really thinking about their program, their machine learning program, what it can do, can use the data about the execution to improve or detect these problems, right? So that is visualize. But once you think about it, if software can bring all of that together, right, why can't it analyze all of this data itself? Literally, applying the same things that an application developer is using Spark for, do the same thing for all the data collected about the system and the execution, the cluster, and things like that, and help the developer guide them to what the cause of the problem might be, and better, guide them towards a fix and fix it for them, right? So that is optimize. And great, okay, if you can visualize and bring everything together, you can analyze it and optimize, can this software also help you plan, strategize, prevent these problems from happening, help you become a better developer based on the things that you're doing and learn from that entire experience, right? So what we are going to do is we are actually going to show you a quick demo, right? And we are going to show these things in a software that we have actually been building and collaborating together. It's software that we would like to put in the hands of many people, and we will definitely be looking for more beta testers, and I'll make that announcement at the end of the talk. So let's start. And before we jump into the demo, Lance, can you give some context on what led us to this demo?
Yeah, so in a very high level, this is one of the sample applications we have at Box. Made it a little bit easier, but in the end of the day, it's a label propagation algorithm. So basically, you have nodes in the graph, and certain nodes have labels, and you want to see through some convergence in number of iterations how these labels spread across your graph. So you're predicting labels of nodes. And yeah, so this is an application we're going to unwrap through this demo.
So this is the UI. Give me a moment to make it full screen. So what you're seeing here is the Unravel UI for a Spark application. So this is the label propagation application, a representative of some of the things that Lance is building on at Box, right? So the very first thing is this is intended for an application developer. It has some use cases for operations people as well. And what does the application developer know? They created this program, right? This is a Scala program, this in a general purpose programming language. So the application developer knows the program, and that becomes entire interesting execution in Spark. So this is the directed acyclic graph of RDDs and stages that Lance was actually talking about. That then becomes an execution in the cluster. So when there is a problem, right? The application developer wants to understand the execution in the context of their program. So it's great to see a DAG like this, but won't it be even better if she could click on one of these RDDs and see where in their program actually that particular reference to that RDD is happening. Where is it being created, right? So this helps them give a lot of context to the execution in terms of things they know and understand, right? And the same logic, many of the things that we'll be showing here for Spark, they apply to Hive running on Tails, Hive running on MapReduce, cascading, because the principles of application management and simplifying application development cut across many of these application development languages and systems, right? So the second thing you will notice is often when you're trying to understand, as I said, understanding what the program is correct, debugging it can be pretty hard, right? So what is the execution at the end of the day? It's a data flow. So wouldn't it be great if that framework could show me some sample of records flowing through, right? So that's what we're seeing here. As I'm clicking on these RDDs, you can see a sample of records. This is pretty interesting because keep in mind that the execution of Spark is cut into these stages. If you can see here, maybe I should increase it a little bit. So you can see the tag. So notice how this RDD is part of stage 0. All of these RDDs that are part of stage 0 will be run in a pipeline fashion in one task operating on a partition of the data, right? So it's an interesting execution flow. And while that is happening, we are able to extract a sample of records and show. So the developer is able to debug and understand the data flow, right? And once you have understood the data flow and verified that things are correct, right? The next thing you probably want to do if you are facing a performance issue, that is, you want to know what really happened in the cluster when things ran. Because the RDD and everything is generated on the client side, on the, this entire DAG is generated on the driver side. So increasingly you'll notice how we have tried to piece together the information about the application in a nice sort of drill down fashion, so you can go from the top level to in a more and more increasing level of detail. So what happens on the cluster is these stages, they actually run as jobs in the cluster, right? So you can see here, this is the set of stages that actually ran. So overall, the query took around 17 minutes. So this program took 17 minutes to run. And the bottleneck is really that first stage. So now what you'd like to do, maybe if you want to fix that bottleneck, you want to drill down and understand what is that stage doing, right? How is it running in the cluster? So what you see here is, again, these stages run on a data that is partitioned. Each partition leads to a task that runs on some machine, right? And when you have many tasks that run, especially in parallel execution, a big problem is a load imbalance or skew, right? Sometimes, some tasks will get a lot of data to process and they could be slow. So what you're seeing here is a histogram in this particular stage had 44 tasks. This is showing the time of execution, the y-axis is the number of tasks, and the x-axis is the binning of a histogram of times, different bins of time. And interestingly, you'll notice in the middle histogram that, hey, 41 tasks process very little amount of data. 3 tasks process a lot of data, right? You might be thinking you had to tune it, hey, those 3 tasks might be the bottleneck in my job. interestingly, in this particular case, that's not true. You can zoom in into those tasks, see that those tasks are actually the ones which are like running pretty fast. So something might be going on here, right? So in the interest of time, like I'd be more than happy to show you like what really was going on in here. But just to kind of continue with the story on how to like visualize and put all the information together in a way that the application developer can quickly make sense of it, you want to probably see the configuration, the logs, and maybe the resource utilization on the cluster, right? When your different executors were running, how much like CPU were they using? Is there any imbalance? Maybe some machines were actually like running other things or contented, or maybe had a bad disk and was actually like causing a bottleneck in your job. So quickly, nicely piece all the data together so that the developer can basically understand from the perspective of the program what is happening in the cluster, diagnose, debug, tune, right? Well, it's all great to have a visualization. Like visualization is always great, but won't be even better if the sort of analysis of the data can be done, as I was saying, the optimize, where we're getting into the optimized regime where the system analyzes that data and tells you, hey, look, I looked at your application, and based on the data I'm seeing, I suggest that you should be caching this one RDD, right? So as Lance pointed out, when you're a machine learning developer or like a BI analyst, like caching and all of these low-level things are probably not what you think about when you're writing your program. What do you have to think about? And yesterday it was MapReduce, like in the morning it was Trace, maybe right now it's Spark, right? And Flick might be the next thing. And how much do application developers have to know to be able to deal with problems like this, right? So events is one way in which we are trying to analyze all the data, bring it together, and then suggest, it's like a big data expert, a Spark expert sitting there and guiding you and telling you what could actually be wrong with your program and how you can go about like fixing it, right? So what is very interesting in this particular case, and the reason we picked this demo is that, hey, like this is actually not the first execution that Lance did. The first execution he did ran into those, this is what he got, right? He did an execution and was seeing a lot of these like stack traces. The program was failing, right? And what did he have to do? Like before this tool, what he would have to do is like look through these stack traces, understand what is going on, look at these numbers, and only a few people can truly do it. Like if you want Spark in the hands of a lot of people, like you don't want them to like dig through logs and stack traces like this. With Unravel, what we are doing is we are again doing all of this analysis and bringing these exceptions and errors in a pretty nice fashion that a developer can understand, right? Especially tell them, look, this is an error we saw, right? And the same error was repeated many times because many tasks fail with that same error, right? So we are able to tell the developer, look, this was the problem that happened, and we can pinpoint which, like RDD, which transformation had that particular problem, right? So let me quickly show you how a user would kind of use this. They would see that, hey, it's RDD number 5. Okay, I can go to RDD number 5 and check things out, right? So is this particular line? That was the cause of the problem in probably a pretty large program, right? So if you have been paying close attention to the error message, you will know that this error is happening because this particular developer, Lance, who's an expert developer, by the way, did a problem that, did something that you should not do in Spark. You should not have an action inside a transformation, right? When you're writing a large program, some of these things can be like, hard to kind of figure out. So look at the program, line number 59, right? Hey, Lance, don't do this, right? He put a count inside a transformation, right? And without a tool like Unravel, it becomes pretty hard for the developer to kind of zoom in and understand what is happening, right? So that was the optimize, like analyze the data and tell the user what could actually be happening. So as I said, like strategize, help them prevent these problems in the first place, right? The way we are actually attacking that problem is once you're running programs like this, right? We analyzed one program, but in a company you might be running a large number of Spark programs, Spark SQL queries on a day in, day out basis, right? Collect all the data, right? Extract these events from those programs and group them and tell an operations person, or even better, tell the developer that these are some common problems you're making, right? Help them improve over time. And this can be done very effectively by sending this sort of like, this is a digest that the user gets at the end of every day, which actually lists all the problems or the inefficiencies that we were able to detect for them. And you can click on these applications, go to the actual application, quickly check things out, make things very, very easy for them. Present that data in a very nice fashion. And same type of problem that we saw, right? Many other developers might be making. So we can use this information to help the not so experienced developers learn from the more experienced ones. So there's lots of potential in addressing problems like this. And we are constantly, we call this our inefficiency hunt. We're constantly on the lookout for common types of inefficiencies. And this is where we would love to get more feedback from the community on what are some common problems that you face, like you have faced as you learn Spark, right? Or as other developers in your company face, or they actually experience on a daily basis, right? All those failures, inefficient applications, Tom's query bot, the cluster down, whatnot. You would like the software to be able to help out those developers so that they're not making the problem again, and again.
Yeah, so just to wrap everything up into one very concrete sphere. So at the end of the day, we're all application developers. We write machine learning algorithms for real-world use cases. So there's a problem we identify in the real world, and we really want to do some sort of prediction, let's say, on it. So on the high level, you sit down, you write your program, and that's really what you go through in the first iteration, and you don't really think of everything else. So what we did together through this Spark Unravel tool is allow you to visualize, first of all the data in one place. And what that means is gives you an inspection of your program, gives you data samples of how your data is being transformed at that particular stage, and even highlights the line number that you are at that given point in time. The next thing, we visualize on an application logic layer, on a much deeper level, you also want to get a perspective on task level, stage level metrics, and that's all there, and we show that to you as well. So after seeing that, again, you're an ML developer, you really just want to focus on your use case. So at the end of the day, small things like which RDD should you cache, should you or should you not checkpoint a particular RDD? Did I give enough resource allocation to my workers, to my drivers? So these are all settings that we can set, but we're really not sure how to set them, because until you see data as it transforms in your pipeline, you don't really know if the data is going to fan out, get bigger or get smaller in the pipeline. So things like optimization is all wrapped into this tool. It'll tell you of the resource wastages that you may be incurring. And finally, on the bird's eye view, this application, how it tunes into all the other applications running on the cluster. So this is the strategized part. It comes in and says, hey, these are the common problems on a high level that applications like yourself would encounter. So when we deploy something in real life, you would mostly have it automated. Let's say you have a machine learning job running on a day-to-day basis. So very obviously and very easily, you can predict trends, how long should a particular stage be for this application. And because you have historical data, you can very easily imagine that Unravel can tell you, hey, this particular stage historically only takes 2 hours. Why is it taking 8 hours right now? There must be something wrong. So yeah. All these things wrapped in, it's pretty much what we've shown you today, and we hope the messages come across clearly. And so I think we're good, and we're here for questions if there are any.
So quickly to wrap up, this is software that we've been building for a while. Now we are inviting more users to kind of test it out. So there's only so much we can do building it at a university, and also working with real programmers and people building applications at Box. So here is a website you can go and sign up for early access. So I just want to warn you that this is something which will be slowly working, and we want to, before we release it to everybody, we want to ensure that the initial experience is going to be smooth on how all the data can be brought into Unravel. And hey, we are also hiring. We are looking for smart people to help us all the time. Thank you. Questions, please.
You mentioned earlier in your talk that one of the sources of problems can be poorly defined user queries. For example, if we're exposing Spark Thrift server to other users inside of the company to do their own queries, there will be poor queries. Have you guys come across good ways for filtering out queries that are obviously going to bring down the cluster?
So the work that we have been doing, so as I said, like this entire project in some sense started in 2009 when we saw MapReduce as that first general purpose programming language that people want to run against big data. So since that work with MapReduce, we have been supporting Hive, Pig, and cascading. So one of the things that we have built over time, and this is what we want to do for Spark as well, one thing we have built over time is like everything that is running on the cluster we monitor, we bring in, okay? So then we can start grouping your queries like into templates and basically identifying common types of queries that are causing problems in the cluster. So now when a new query is actually posed or a new program is written, we can extract some signatures, and there is some research work that we have published on it. You can extract signatures from the program, look up that database, and then give the application developer some insights into how that program might run. So this is a way in which we have actually attacked for Hive, like bad queries that can bring the cluster down. We haven't done it for Spark, but that's definitely one of the key things in our roadmap.
I have a two-parts question. First is, how is it integrated, and do you have any plugins for the developers to use it in Eclipse or something?
Well, who develops with Eclipse, right? Everybody writes command line programs like this, isn't it? Anyway, so as you probably saw, right, there are different types of data we need to bring in, and one of the types of data, and this is not crucial to have, if you don't have the program, the source itself, there are certain things we'll not be able to, nice things we'll not be able to do. So the way we have been working is, identify the common ways in which people submit programs in a standalone Spark cluster, in a Yarn Spark cluster. Mesos is something we haven't worked with yet. And basically with minimal, and this is like a key thing we believe in, with minimal changes required for the developer, the application developer, as well as the Spark developer and committer, right? We want to capture all of this data. So we tap into all the data sources that Spark already has, and then do some things on our own as well. So far, we have pretty much support the command line ways of submitting it. Hue is one system. If you notice that some of the queries came from Hue. Hue is a system that we are trying to integrate with. Eclipse and IntelliJ will probably follow, right? That will require more engineering efforts, and we are right now focusing on solving some of the hard problems and creating some value out of this. But that's definitely, again, I want to say it's in the roadmap. I don't know when we'll be able to get to it, but if there are people who want to help us out, then we'd definitely love the community effort on that. More questions? I think we are done. Thank you.